In this video, we'll talk about how you could tell that you have picked the wrong u. The idea is if you cannot rewrite the whole integrand, the whole function that you're trying to integrate in terms of u, you should try a different u or some other method. All right, so let me show you in two examples what it looks like when you didn't pick the right u. But before that, I just want to remind you of the two clues that we had. All right, so when you're trying to pick u, clue number one, u is inside another function, inside brackets, inside exponent, inside roots, inside the denominator. That's the first clue. Clue number two, you should be able to spot g prime of x inside the integral somehow. So g prime of x dx is inside the integral. So we saw a bunch of examples. Let's look at two more. All right, so I have the integral of secant squared over tan squared dx. All right, so I have secant inside a function and I have tan inside a function. So let's try both. All right, so I want to show you which one's the right one and how you could have been able to tell from the start. All right, so u equals secant, then the derivative of secant is secant x tan x. Now already I'm a bit worried. I have secant and tan, but I don't have secant x tan x multiplying dx. Might still work out because I do have something similar. So really here, I get that dx is 1 over secant x tan x du. So my integral, if I try to apply that substitution, would give secant squared of x over tan squared of x, 1 over secant x tan x du. One of the secants cancel, so I get secant of x, and then I have tan cube of x du. At this point, I need to rewrite secant in terms of u. That's easy, since u is secant. And then I need to write tan cube. Don't know how to do that. I mean, we do have that secant squared, and we'll use that in a bit, is 1 plus tan squared. And so I could get tan squared, but tan cube, it cannot. I can only get even powers. So here, this one, I can't rewrite it in terms of secant x. That's my u. I can't do it, so this is wrong. Part of the problem is what I have here is not canceling the whole tan squared that I have extra that doesn't look like a secant. All right, let's try u equals tan of x now. If I try u equals tan of x, du is secant squared of x dx. Now I like this. I have secant squared of x dx. That's the whole difference here. That entire part, the fact that I have g prime of x dx in my integral tells me that this is right and that this wasn't. Right? This is much better because not only clue 1 works because I have tan inside a squared, but clue 2 works. I have my secant squared dx. And so when I rewrite it, I don't even need to use dx to solve for dx, right? I'm just going to replace the top by du. And then tan squared is u squared, and done. All right, this is much better. Well, on top of it, this one doesn't work, but even if it worked out, this works out so nicely, and the integral I get is so simple. That's perfect. All right, so this is u to the minus 2. And so I get u to the minus 1 over minus 1 plus c. I get minus 1 over u plus c. And so that's minus 1 over tan of x. Let me just shrink this or put it up a tiny bit to make sure we're not in the way of the next problem. All right, so let's try another one. Let's try the integral of x squared 1 plus x6 dx. I think the most obvious one to try is 1 plus x6, which is in the denominator. I mean, I guess you could say that x is inside x squared, but if you take u equals x, all you're going to get is exactly the same integral, but you're just renaming x u. Just changing the name, but you're not changing anything, so the integral doesn't get easier. So this is a substitution that you should never take. I mean, it's never wrong to do it, but it doesn't lead anywhere. It just rewrites the integral in exactly the same form with a different variable, and so I'm never going to give you partial marks for this. It doesn't show any insight, doesn't show any understanding. All right, so first try, we said I have 1 plus x to the 6 in the denominator. And so du would be 6x5 dx. All right, already I'm thinking, uh-oh, I have x squared, not x5. Maybe it will work out, so let's try. If I isolate dx, I'm going to get 1 over 6x5 du. And so the integral is going to give me 1 over 6. That's fine. Some of the x squared, well, the x squared was going to cancel with some of these. I'm going to be left with x cubed. So I have 1 plus x6 x cubed du. All right, so this part is fine. This is u, but that part. So if I look back at what I have here, x6 would be u minus 1, so x cubed. I need to take a square root, but I don't know if it's plus or minus the square root. So I don't even have a function, right? And I can't integrate anything like that. Not only is it a mess, and it's worse than what I started with. This is much nicer than what I'll get here, but it's not right because I have two different functions. All right, so we'll see in a few videos that things like that can sometimes work out, but that should not be your first choice. And in this case, it doesn't work out. All right? So let me try something different. I'm going to try something different, but staring at the function doesn't help me much. However, I've seen x squared here, so it seems like I should take x cubed. All right, so then I'll have g prime of x dx on top here. All right, so that clue is guiding me towards this, but I need to make sure it's going to work. I don't want to waste more time. So what I'll do is I'll rewrite this. And I want to show you that this x6 is actually hiding an x cubed if I write it this way. If I gave you this integral, this is an obvious choice. Didn't mean to write through it. This is an obvious choice. I have x cubed inside. I have something like the derivative on top. But because I wrote it like this, because I simplified it, it became a much harder problem. So it was your job to see that inside the x6 you had an x cubed, and so this was a possibility. It's the right one because I have 3x squared dx, and that's going to eat up the x squared. If I had an x5 on top, this would be the right substitution to take. All right, so here 1/3 du, that will be what I have on top. So my integral is 1/3 du over 1 plus u squared, and I get 1/3 integral of 1 over 1 plus u squared. That's one of the basic one. It's arctan, so I get 1/3 arctan of u plus c. And so 1/3 arctan of u is x cubed. And that was it. In the next video, we'll be looking at examples like this, where doing this kind of algebra will actually work out, and that will give us answers for harder problems.